different types of graphs of numerical data. Now here in this example, we have birth weights of 10 babies, 103 ounces, 106 ounces, 48 ounces, 96 ounces, and so forth. One type of graph is called a stem plot or stem and leaf plot. The stem would be the first one or two digits, the leaf would be the last digit. And so the lowest birth weight is 48, so the lowest stem is going to be 4. And the highest birth weight is 117, so the highest stem is going to be 11. So we can make the stems go from 4 to 11. We could go lower than 4 or higher than 11, but we really only need to go 4 through 11. Okay, so then we can fill in the data. So 103 would be row 10, column 3, would be the 103 ounce baby. The 106 ounce baby, row 10, and I put a 6 in row 10. And the 48 would be an 8 in row 4. 96 would be a 6 in row 9. 110 is a 0 in row 11. 98, 8 in row 9. 104, a 4 in row 10. 85 is a 5 in row 8. 117 would be 7 in row 11. And 103 is a 3 in row 10. Okay, so this looks like, in row 9 it looks like 68, but it's really 96 and 98. And then row 10 it looks like 3,643, but this really 103, 106, 104, and 103. And then the next step is to put the leaves in order. The only row that's not in order is row 10. We want them in order from smallest to largest. Okay, so the rest of it's going to be the same. We have the 48, 85. Row 9 we have the 6 and 8. Row 10 we want to go smallest to largest. So we have 3, 3, 4, 6. And then row 11, 0, 7. So that's our stem plot. And then, so now we can use that to interpret data. And for that, it might be helpful to turn our graph sideways. So the longer tail is on the left here. So it looks like it's skewed left. It looks like one main cluster skewed left, and possibly an outlier of 48 ounces here. So skewed left is the longer tail is on the left. Symmetric, left side is the mirror image of the right side. Skewed right, the longer tail is on the right. Bimodal would be there's two main clusters. Uniform means it's all the rows are more or less even, or close to being even. But so this looks like it's one main cluster and skewed left, and maybe an outlier of 48 ounces. Generally, but not always, if the data is skewed left, then the mean is less than the median, and the median is less than the mode. If the data is skewed right, then the mode is less than the median is less than the mean. So the skewness can affect the statistics. Okay, so another type of graph is a histogram. And the histogram, we first want to group the data, and we can use our stem plot to group the data. We have one baby in the 40s, so the frequency would be 1. Nobody in the 50s, 60s, 70s, so those are all 0. We have one baby in the 80s, 2 in the 90s. We have 4 babies at 100 to 109, and 2 babies 110 to 119. So we can use our stem plot to group the data, and then we make the bars go up to the appropriate number. So in the 40s, we have 1 baby, so the bar goes up to 1, and then nobody in the 50s, 60s, 70s. In 80s, we have 1 baby again. The bar goes up to 1. 90s, we have 2 babies. Bar goes up to 2. 100 to 109, we have 4 babies. The bar goes up to 4. And 110 to 119, we have 2 babies again. So again, it looks like we have one main cluster and skewed left. We could also use the relative frequency or the percent. So at the frequency, we have 10 babies. So the relative frequency for the 40 ounces is going to be 1 divided by 10, which is 0.1. And if we multiply by 100, that'd be 10%. And then nobody in the 50s, 60s, 70s. 80s, again, we have 1 baby in the 80s. And 1 divided by 10 is 0.1, multiplied by 100 is 10%. 90s, we have 2 out of 10, 0.2, multiplied by 100 is 20%. 100 to 109, we have 4 babies, 4 over 10 is 0.4, multiplied by 100 is 40%. And then 100 to 119, we have 2 babies, 0.2, 20%. Okay, so then we can do, except for the scale, the graph is basically going to be the same graph. We have 10, in the 40s we have the bar going up to 0.1, and nobody in the 50s, 60s, 70s, 80s goes up to 0.1 again, 90s goes up to 0.2, and then we have 100 to 109 goes up to 0.4, and then we have 0.2 again. So it's the same, basically the same shape. One main cluster skewed left, outlier in the 40s. And as a percent, it's still going to be the same. 10% in the 40s, we have 1 baby. The 10% in the 80s, also 10%. 90s, 20%. 100 to 109 ounces, we have 40%. And then 20%. Another type of graph is a dot plot. For dot plot, we just put a dot for each baby. So we have a 48 ounce baby, we put a dot there. We have a nobody in the 50s, 60s, 70s. We have an 85 ounce baby, 96 and 98. We have 2 babies at 103, so then we stack the dots there at 103, 104, 106, 110, and 117. So again, one main cluster skewed left. we have an outlier of 48. Okay. We also do a pie chart. Pie chart, like the histogram, we could use the same grouping we use for the histogram. We had one baby in the 40s, nobody in the 50s, 60s, 70s, one baby in the 80s, two in the 90s, four between 100 and 109, two between 110 and 119, and then we have 10 babies, so we want to divide the pie into 10 pieces, and so the hi.
You want a phone?
Yeah. I'll be done in a few minutes. One baby, 40 to 49 ounces. One baby, 80 to 89 ounces. Two babies, 90 to 99, so that's two slices of the pie. Four babies, 100 to 109 ounces, 1, 2, 3, 4, that's four slices of the pie. And two babies, 110 to 119 ounces. Pie charts are not used much in professional publications. They're used in popular publications. They take up a lot of space for the amount of information they convey, so it's not used so much in professional publications. In the professional publications, you're more likely to see stem plots or dot plots or box plots, which is covered in a different assignment, or histograms. And that concludes this presentation.